Okay, let's consider how to factor something like this. So it is a trinomial. That means it has three terms. So 1, 2, 3. So it's a trinomial and we're factoring. Anytime we're factoring, we want to try to factor out the greatest common factor. But I want you to look at this. This does not have a greatest common factor. There's nothing that each term has in common. The last term does not have an x in it. The other two do. We have a 3, a 10, and an 8. There's no number that goes into all of those other than 1, and 1 doesn't really count in terms of a greatest common factor. So that's the first thing we check. There's no greatest common factor. So then because it has 3 terms, we want to, oops, the light went off there. We want to set up 2 sets of parentheses like this. This is called the guess and check method. So I'm putting down 2 sets of parentheses, and we really want to think about this as having 4 blanks to fill in. So we have 4 blanks to fill in our parentheses. And in the front set of blanks, there's really only 2 things that'll work. There are only 2 things in the whole world that multiply together to be 3x squared. So that's 3x and x. Now I could have placed the x over here and the 3x over there, but it doesn't really matter because we're multiplying these 2 things together. The order's not really important. Usually we put the bigger coefficient term here first, so that's why I have it the way I have it. So 3x times x is 3x squared. And what we're doing is we're kind of doing the inverse of the FOIL method. So I'm guessing some things here, and this is not too hard of a guess because it's the only thing that works to get 3x squared. So 3x and x. And so this times this is that. So I'm certain about those terms. Now the other 2 terms are going to be a little bit more difficult because what we pick has to multiply. These have to multiply to be -8. And there's a bunch of things that multiply to be -8. So -8 and 1, +8 and -1, -2 and 4, 2 and -4. So there's at least 4 different things, and we could arrange those a number of ways here in the parentheses. But we have to do it in such a way that this multiplication, in other words, this times this and this times this, those outer and inner terms have to add to be 10. So that's why this is called the guess and check method, because you might place 8 here and 1 there and rearrange the signs, and it might not work. It might multiply to be -8, but it might not do this multiplication here and add to be 10, the middle coefficient. And you just keep trying until you hit the right combination. So you understand what I'm saying by these drawings here. So I'm saying where you have to multiply 3x times whatever you put here, and then whatever you put here times x, you have to multiply those and then add them together to get 10. So this is mental mathematics. You might have to try quite a number of things. Anyway, at some point you're going to come to this conclusion, and I would use a pencil with an eraser so that you can try a lot of things. Well, notice that -2 times 4 really is -8. And when you do 3x times 4, you get 12x. And when you do -2 times x, you get -2x. And when you add those together, you get 10x, which is this middle term here. So this is the factorization of that trinomial by guessing and checking. So that is a method that's called the guess and check method. And there are some other methods that make this a little bit easier, so we'll talk about that next. But that is the guess and check method. So now let's consider the same problem but a different method. Now this method usually has the letters AC in it somehow. So there's an AC grouping method that's old school, it's as old as I am. And then there's a relatively new AC method. Some people call it the extended AC method. I taught with a teacher one time. His last name was Waddell. He claimed that this method was his. It may be so, but it's been on the internet for a while. So it is some version of an AC method. So I want you to watch this. This is a trick that works. So we're going to multiply A times C and get -24. The reason I said A times C is because As a quadratic, this is ax squared plus bx plus c. So every quadratic is in the form of ax squared plus bx plus c equals 0, where the a cannot be 0. So I'm saying the a term times the c term is negative 24. Now think about what multiplies to be negative 24 and adds to be 10. So it has to multiply to be negative 24 and add to be 10. And notice there's only two numbers that do that, and it ends up being 12 and negative 2. So 12 times negative 2 is negative 24, and it adds to be 10. Everything else is not going to do that. So you might try to use 6 and 4, but you're not going to be able to get negative 24 and positive 10. So it has to multiply. These two terms have to multiply to be negative 24, and they have to add to be 10. Anyway, so it's that. So what I do is I write these down, and I put a little fraction bar here. So I wrote 12 and negative 2, and I put a fraction bar. Underneath there, I put 3x, which is the first term over here. So 3x underneath there. And then you reduce these. Well, there's no way to reduce 2 and 3, but you could reduce 3 and 12. Notice 3 goes into 3 one time, and 3 goes into 12 4 times. So I reduce that. Now I'm going to set up my parentheses like this, and I'm going to go bottom up. So this is x plus 4, x and a positive 4. And this is 3x and minus 2 as I go bottom up. And notice that's the same answer we got in the previous factorization. Now the parentheses are in a different order, but again, because we're multiplying, that doesn't really matter. So this is the same thing as this. So this answer here is the very same thing as this, just in a different order. And because we're multiplying, that's an equivalent solution. So it doesn't matter whether you write it this way or whether you write it that way. It's the same thing. So this is called some kind of AC method. It's a version of the AC method because we multiplied A times C. This is a little bit easier than guessing and checking because you don't have to do so much mental math to kind of figure out what things are. So it's a pretty good trick that works. So I recommend that as a method. So now let's change this up a little bit. Suppose the problem said solve instead of factor. So notice it has an equal sign in it and it says solve. To solve means to find the x values that'll make this statement true. So I've cut to the chase here because we just factored this and I'm using this factorization. So in order to do this problem, you set each one of the factors equal to 0. So I'm taking each factor here. This is a factor. This is a factor. I'm setting them both equal to 0. This procedure is called the zero product property. The zero product property. And basically this zero product property says that if you have two things or three things or any number of things, and they're being multiplied together to give you 0, then one of those things has to be 0. That's what this says. So we're going to take each factor here and set them equal to 0 and solve. So if you solve this one, you're going to add 2 to both sides, which will give you this. So if I add 2 here, I get 0, and I add 2 here, I get 2, and then divide by 3. You get 2/3. And so we're saying if you take 2/3 and you put it up here for x, you put 2/3 there, you put 2/3 there, and you do the math on your calculator, you will get 0. The other one here, if you subtract 4 from both sides, you're going to get x equals -4. So if you subtract 4 here, you get 0. Subtract 4 here, you get -4. And so we're saying if you put -4 in here for x there and there, and you do the math, you will get 0. So we have two solutions here to this. So there's a difference in factoring and solving. So when we factor, we're breaking this into things that multiply to be the original. But when we solve, we're actually finding out what x is to make this a true statement when we put it back in.